Greetings, fellow explorers of the known and unknown. I'm Ernis, your guide through the labyrinthine world of academic research. Today, we're embarking on a journey to understand how cutting-edge AI can help doctors detect prostate cancer more accurately and efficiently. Ever wonder how AI could revolutionize medical diagnoses? We'll be diving into a fascinating paper titled ProstNFound+, a prospective study using medical foundation models for prostate cancer detection. Now, that's a mouthful, isn't it? But don't let the jargon scare you. We're going to break it down into bite-sized pieces, seasoned with a dash of cosmic wonder and a sprinkle of down-to-earth analogies. Imagine, if you will, a vast cosmic ocean of medical data. Within this ocean, countless tiny micro-ultrasound images of prostates swirl around like galaxies. Our challenge? To find the subtle, almost invisible patterns that indicate the presence of clinically significant prostate cancer, or CSPCA. Now, to navigate this cosmic ocean, we need a starship, and that starship is ProstNFound+. This isn't your run-of-the-mill AI model. It's a highly sophisticated system that combines the power of medical foundation models with some clever adaptations. Let's start with the key idea: medical foundation models. Think of them as pre-trained AI brains that have already learned a lot about medical images. It's like giving our starship a seasoned captain who already knows the constellations. The problem is, these general-purpose medical AIs don't know much about the specific quirks of micro-ultrasound images of prostates. That's where ProstNFound+ comes in. It fine-tunes the AI, adapting it to the specific task of detecting prostate cancer in these images. Alright, let's build our memory palace to truly grasp the architecture. Picture a magnificent, multi-story medical research facility. First, we enter the image encoder room, the heart of our facility. Here, micro-ultrasound images are fed into a vision transformer, a powerful engine which processes the images into rich, high-dimensional embeddings. Think of it as extracting the essence of the image, distilling it into a concentrated form. Next, we ascend to the prompt encoder suite. This is where things get interesting. Instead of just feeding the AI images, we also give it clinical information about the patient, like their age, PSA levels, and PSA density. This data is processed and embedded, providing context to the AI. Imagine it as providing the AI with a map and compass, guiding its search. Now, let's head to the fusion chamber, where image embeddings and clinical prompts merge. This is where the magic happens. The model learns to associate the image features with the clinical context, creating a powerful synergy. Finally, we arrive to the multi-head output observatory. The observatory has two windows, one to determine cancer localization and one to determine the risk score. Through one window, we see a cancer heat map, a visual representation of the likelihood of cancer in different regions of the prostate. Through the other, we get a risk score for clinically significant cancer. But wait, there's more. These researchers didn't just build this amazing system, they put it to the test in a real-world prospective study. They trained ProstNFound+ on retrospective data collected from previous studies, and then unleashed it on new data collected 5 years later from a different clinical site. This is crucial because it tests the AI's ability to generalize, to perform well on data it hasn't seen before. And guess what? ProstNFound+ passed with flying colors. It showed strong generalization, with no significant performance degradation compared to the retrospective evaluation. Now, I know what you're thinking. Fine, yeah, AI can detect cancer in images, but how does it compare to the experts? Well, the researchers benchmarked ProstNFound+ against standard clinical scoring protocols like PRI and PIRA, and while the AI didn't quite outperform the human experts, it came pretty darn close. The results showed that ProstNFound+ achieved an AUROC, area under the receiver operating characteristic curve, of % compared to % for PRI. Look, the point is, this is a big deal. It demonstrates that AI is rapidly catching up to human expertise in this critical area. But here's the most exciting part. ProstNFound+ produces interpretable heat maps that highlight suspicious lesions in the prostate. This allows doctors to see where the AI is looking, providing valuable insights and potentially guiding biopsies. So, what does all this mean for the future of prostate cancer detection? Well, ProstNFound+ offers a scalable and interpretable alternative to expert-driven protocols. It has the potential to improve accuracy, reduce inter-observer variability, and make advanced diagnostics more accessible, especially in low-resource settings. Of course, there's still work to be done. The AI needs to be refined and validated in larger, more diverse populations. But this study represents a significant step forward in the quest to conquer prostate cancer. So, the next time you hear someone say that AI is just hype, remind them of ProstNFound Plus. Remind them of the cosmic ocean of medical data, the starship that navigates it, and the potential to save countless lives. Thank you for joining me on this journey of discovery. Until next time, keep exploring, keep questioning, and keep looking up at the stars.